We're going to explore something extra after understanding, how merging redirection work. I would like to introduce an example here, where what we are trying to do is actually switch STDOUT and STDERR, for example. So let me go back to our standard diagram. STDIN is coming here into my script, my program, my tool, my process, whatever. STDOUT is where it should be. File descriptor 1, this is a screen by default. STDERR is a screen by default, the terminal, and it's on file descriptor 2. Okay, and what I want to obtain, my end result is this STDIN not modified goes in file descriptor 0, 1, 2, and 2 needs to be on STDOUT, and 1 needs to be on STDERR. And it's a little bit tricky right now with the tools that we have. So if you like a challenge, I suggest you you pause the video right now, okay, and you try to solve this using using pretty much the tools that we have introduced so far, which are simple redirection, append redirections, and then like joining, merging redirections like this. Okay, try to solve this problem with those tools. Play a little around with them. There's a possibility you're going to find out how to do it. Then in that case, resume the video, double check that you found out the right way to do it, and then or an alternative way that I'm going to introduce. Okay. And if you have problem, it's not time wasted at all, because then if you try for like 30 minutes but you cannot solve it, all the different things that you try to do are going to help you better understand what's going on with the simple redirection, etc., and therefore prepare you better for the rest of this video. Okay, so either way, whether you find it or not, it's not a big deal. What matters is that you get some practice, some opportunity to rack your brain here and use what we have been studying so far. So I'm going to assume that you unpause the video now if we are going to resume, so we can resume. So I'm going to start by considering what we could do with the tools that we have at our disposal, right? So here's a problem. This is my initial state, okay? So if I start by doing one of those things here, okay? So I have STDOUT, and now I have STDOUT. So whether I put, a number 2 on whatever number 1 points to, which result in both being STDOUT, or I do the other way around, something that we have not been doing a lot in the videos, something like 1 greater than $2, okay, which would result in STDERR here, then STDERR right here. Okay, so that would be the second thing I could do. What's interesting about those two possible strategies? Well, the problem with those two strategies is that in this case, in the top case here, well, I simply lost STDR. Okay, so no matter what I do, whatever remember, I'm trying to switch, right, STDOUT and STDR. No matter what they are, they can be files, they can be, we're going to see in other videos, pipes to other processes, but they can be the screen, it doesn't matter. So I'm just assuming that these are two abstract things that I call STDOUT, STDR, that can be pointing to whatever resource, and I just want to swap them without knowing what they are, okay, without losing the information I have already about what they are, that is referred to by file descriptor 1, file descriptor 2. So here, by just doing this, I just lost the information. And here I lost information, but this time I lost STDOUT. Okay, so it's kind of like the problem of I have two variables, right, x and y, and I have a value here that's 42, I have a value that's 99, and I want to swap them. Okay, so this is a programming problem. How do I do this? Well, I assign to x the value of y, so that result in x being 99, and y being, 99. Well, that's not going to work. I assign, so that was my first attempt. My second attempt is I assign the value of x to y, so now x is 42. I didn't lose that, but y is 42. Wait, this is not going to work either. So the solution for that programming problem generally is to use a third variable TMP, right? To say TMP is assigned the value of x, so x is still 42, y is 99, TMP, which I'm going to abbreviate as T, is now 42. Okay. Then I assign to X the value of Y. Okay, so X is going to be 99. I'm going to write it under. Y is still 99. T is still 42. These have not been changed. And then finally, I assign to Y the value of TMP. So TMP helped me save temporarily the value of X. So I can overwrite X, and then I still have the value that X had originally, so I may assign it to Y in the last step. So it takes 3 steps like this, you know. This is a correct solution. This works. It takes me 3 steps to actually swap those 2 variables, right? Well, I'm trying to do something very similar here. Think about it. I'm going to swap, you know, the file descriptor 1, whatever file descriptor 1 points to. So file descriptor 1 is kind of like my variable X, and I want to swap it with whatever file descriptor 2 points to, which is pretty much my variable Y. So I need, this suggests that I need some form of temporary storage. And this is where we need something that we haven't introduced yet. The syntax we have been using so far for redirection talks about redirecting STDOUT, STDERR, STDIN, which are the 3 first file descriptors of a process in a Linux Unix environment. So 0, 1, and 2, right? But there are other file descriptors. Whenever a program or command or a tool, whatever, a process opens a file on disk, well, it's going to have a file descriptor associated to it, which is going to be stored in that same table at the next index, so index 3. Then index 4 if I open another file. If I open 50 files, I'm going to use 50 of those indexes, right? 50 additional indexes. So that suggests that we have been using numbers 0, 1, and 2 like they are some sort of magical numbers, but they are just really the first elements of our table of file descriptors. So we could use number 3. And the idea here is to use number 3 kind of like we used here the TMP variable, right? We want something that's going to allow us to save temporarily one of our important values, which are in this case, you know, STDOUT or STDERR. So let's try to do this. I'm going to erase a few things here. So we agree that those are not working out. Okay, so we're going to get rid of them. And I'm just going to be lazy here because I don't want to redraw it, so I'm going to keep that one like this. Okay. And we're going to try something different. So, something different we're going to try. Let's go. We are going to do, let's assume whatever this is, okay? This is my tool. It can be my prog.sh. I'm going to probably use my prog.sh when we test that on the terminal, but it could be anything here, okay? This is my command line. So what I'm going to do here is I'm going to try to save this STDOUT. To do so, I need another file descriptor, so I'm going to take number 3. How do I tell that on file descriptor number 3, I want whatever is pointed at by file descriptor number 1? We know the notation for that. Okay, we have been using it a bunch of times already, It's that notation. Okay, and now you see that this is equivalent to saving whatever is pointed to by file descriptor number 1 inside file descriptor number 3. So file descriptor number 3 points to the same thing than the number 1, which is STDOUT, which is in our case, you know, the screen or a file. We don't care what it is. We just point to the exact same thing here. All right, very good. Then what? Then what we're going to do, so that would be our first, you know, redirection. And let me like move things around, because I'm definitely so good at using this lasso tool that I don't want to miss any opportunity to use it in the videos, right? So I'm going to move things around, and I forgot a S here. There we go. And then because that works so well, I'm going to move again everything around here. And of course I miss the S. I'm really not good with that tool. Okay, so there are pieces falling around everywhere. Don't worry about that. This S is getting a little bit stretched. No matter. Okay, we are still pretty much to the point where I'm going to redo it. Alright. I should have done that to start off with. So let's do it again properly this time. STDIN goes in file descriptor 0. Okay, I need 1, 2, 3 this time. Okay, I need one more. The first one is still STDOUT. I didn't modify it. The second one, I didn't modify it actually, STDERR. STDERR, whatever. And the third one, with this first redirection, now what's happening is that the third one is pointing to the same thing as the first one, so that would be STDOUT. You see how this is kind of mimicking what's happening here? My TMP saving the value of X. Well, this would be the equivalent of my TMP here. Okay, and this is my X and this is my Y, and now STDOUT was in X, you know, and it's saved by being in TMP. So that's pretty much, we are doing exactly the same thing here, the same logic. Now, what we want to do is we want to go to the next step of our switching, right? We want to take, actually, we saved already STDOUT, so we want to actually overwrite STDOUT here with STDERR. Okay, so how are we going to do this? Well, we can say that, let me grab the pen again here. We can say that file descriptor number 1 needs now to be redirected to whatever file descriptor number 2 is pointing at right now. So this is a notation to do it, right? So this is going to be our second redirection. The second redirection, what it's going to do is, here goes std in again. Okay, 0, 1, 2, 3, and then so start by the ones that we didn't modify. Okay, STDOUT, very good. Number 2 is still STDERR. And what we are doing with redirection number 2 is we're saying that file descriptor number 1 is now going to point to the same location as file descriptor number 2, so that STDERR here, whatever it was, again, that's the important thing about this approach, we don't care what it was, we don't know what it was, is being is now where our old STDOUT is being redirected to. Okay. And then what? What do we have left to do? When we have to do the third part of the permutation, right? We have to make sure that this STDERR here is replaced by STDOUT. So STDERR for file descriptor number 2 needs to be replaced by STDOUT. So how are we going to do this? Well, we want to modify file descriptor number 2. So the file descriptor number 2 is going to be redirected, and we want it to point to whatever file descriptor number 3 is pointing to. Okay, so again, this should be the last step of our transition here, permutation, sorry. STD in, still the same, has not been modified all along, so 0 is safe here. 1, 2, 3. And then we are going to start again by the ones that are not modified, so number 1 has not been modified, STDERR is still there, right? Number 2 is being modified, is going to point to whatever number 3 was. So what is number 3? STDOUT still. Okay, so now number 2 is STDOUT. Alright, and I have completed this, you know, there's three steps, pretty much, permutation, using file descriptor number 3 as a temporary way to save things. So if I use again my my little program here, okay, so this program sends something to STDOUT, and then send something to STDERR. So we have already covered how to redirect those things. Okay, so here goes redirecting to the out file, the standard output, and here goes redirecting to the err file, the standard error. Okay, and then I can do cat out and err. So let's do them one at a time. Cat out. Okay, very beautiful. Cat err. Beautiful. So this is our base behavior. Okay, now we want to change that base behavior. So what we are going to do is we're going to use we're going to use the same logic here, but we want first to permutate things around. So 3 goes to 1, 1 goes to 2, 2 goes to 3. 3 goes to 1, 1 goes to 2, 2 goes to 3. Okay? 3 to 1, 1 to 2, 2 to 3. Let's double check. 3 to 1, 1 to 2, 2 to 3. Okay. Alright, so if I do this, obviously, well, it's supposedly going to swap around, STDOUT, STDERR. So that means that the message that says this is something for STDOUT should go to STDERR, and the message that says this is something from STDERR should end up in STDOUT. The problem is that because STDOUT and STDERR are the same thing, which is the screen of my terminal here, it's not going to really show anything interesting. Okay, I cannot really validate anything here. So what I want to do that is what I want to do now, sorry, is I want to use this and merge it in with this. Okay, so we know already that if I just put slash, greater than out, 2 greater than air at the end of my previous line, it's not going to do it. It's not going to do it because I'm going to modify those two file descriptor 1 and 2 after the fact, after they have been already shuffled around. So what I want to do instead is I want to take this line, and before I try to do the swapping around, I want to say, well, my initial, my startup situation is that I redirect STDOUT to the file named out, and STDERR to the file named air. Okay, so instead of having both STDOUT, STDERR pointing to the screen of my terminal and then swapping them around and then I cannot see exactly what happened, I'm going to have them point to very different files to start off with, then I'm going to swap them around and see if that worked. So here we go, let's try this. I still have like 2 files produced. What is the out file? There we go. We have the message that was sent by my program .sh to standard error that end up finding its way to the out file. Okay, and then if I do cat error, this is going to be the same thing here. You can see that the message that was sent by my program to file descriptor 0, which is normally STDOUT, ended up, because of my complicated redirection, ended up to finding its way to the air file, which was the one that initially I redirected STDERR to. Okay, so this is a very interesting example for several reasons. One reason is that it's kind of like the hardest thing we can do with everything that we've learned so far. So it's always good to have an example like that to wrap up things, okay? To make sure that you understood everything up to that point. The other thing is that it's actually a situation that has practical application. Sometimes you want to swap 2 file descriptors. Well, this is how you do it, okay? So very simple simple usage, a use case that is actually realistic, and something that's non-trivial to do with the tools that we have learned. And then the third thing is that it introduces the IDE that generalizes everything that we have learned so far. We kind of treated numbers 0, 1, and 2 as magic numbers so far. Well, now you can see that you can play with any file descriptor. And you can even use redirection that are using file descriptors that your program itself doesn't use. Okay, there's nothing in my code that use file descriptor 3, but I can use them to temporarily store what was in other file descriptors, etc. So there is that should give you a good idea of the underlying power of the mechanics of stream redirection in any Linux and Unix system. Okay, and like I said earlier on, this is a mechanic that is being used not only in Linux and Unix, being used in different operating systems. It's also a very powerful design technique. Okay, meaning that you can imagine taking several programs and connecting now their STD in and STDOUT together, so that the output of a program goes to the input of another program, right? Well, this is what we're going to discuss about in one of our next video, and this is going to be about piping. So this is going to wrap it up for this video. Thank you for listening again.